Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
Okay, I want to start with a question that sounds like it belongs in a philosophy class at like 2 in the morning, but stick with me.
Uh-oh.
Is your life, your actual life, the choices you make, the things you believe, who you fall in love with, is all of that just a math problem waiting to be solved?
That is a heavy way to kick things off.
I'm serious.
Yeah.
Because we're looking at a book today that essentially argues, if you have enough data and a big enough computer, everything from the air you breathe to the prayers you say is just an equation.
It's a pretty provocative stance, and the book itself, it doesn't look like some philosophical manifesto on the outside. It's this dense brick of a textbook.
Right. We are deep diving into Introduction to System Science with MATLAB, the second edition by Gary Marlin Sandquist and Zakary Wilde. And I have to be honest, when I saw MATLAB in the title, I just thought, okay, we're going to be talking about engineering bridges or optimizing traffic lights.
Yep. And we are. But the authors, Sandquist and Wilde, they don't stop there. They take the tools you'd use to build a bridge calculus, differential equations, computer modeling, and they apply them to, well, everything.
The equation for everything.
Exactly. And that, I think, brings us to the core mission of this deep dive. We really need to figure out, is this book actually doing system science in the traditional sort of philosophical sense, like the pioneers of the field intended? Or is it just treating the entire human experience as a coding problem?
Right, because there's a history here. System science isn't something these two guys just invented to sell MATLAB licenses.
No, not at all. I mean, if you go back to the mid-20th century, you have giants like Ludwig von Bertalanffy.
Great name.
The best. And he's considered the father of general system theory. For him, a system was almost a living thing. He looked at biology, at society, at psychology, and he argued you can't just break things down into pieces. You have to understand the wholeness.
It was holistic.
It was very holistic. It was all about how parts interact to create something bigger than themselves.
So, do Sandquist and Wilde respect that legacy? Or are they just sort of borrowing the buzzwords?
It's a bit of a bait and switch. I mean, they definitely acknowledge the history. There's a specific table in the book, Table 1-2, where they list the prominent system scientists.
He's there.
Von Bertalanffy is right there at the top. They credit him with bridging the gap between the natural and the social sciences.
So they tip their hat to the philosopher.
He do, but then they immediately pivot. While von Bertalanffy was asking, what is the nature of a system? These authors are asking, how can I calculate it? They explicitly define system science as a discipline employing quantitative, analytical, and numerical methods.
So if you can't put a number on it, they're not interested.
Precisely. They are engineers through and through. They view the entire world through the lens of the principle of causality.
Cause and effect.
Right. But for them, it's not just a concept, it's a rule. For a system to be rational, and that's a key word for them, rational, it must have inputs or causes and outputs effects that are measurable.
Measurable. That's the catch.
That is the filter. In fact, they have a whole section on what is not a system. They call them irrational systems.
I love this list. It felt so completely out of place in a textbook. They list astrology, fortune-telling, luck, and reading tea leaves.
Yeah, and it sounds funny, but you have to think about why they exclude them. If you read tea leaves to predict the future, what's the mechanism? What's the equation that links the wet leaves in a cup to you meeting a tall, dark stranger?
There isn't one. It's magic.
Oh.
Or coincidence.
Exactly. There's no transfer function. There's no mathematical logic connecting the cause to the effect. So Sandquist and Wilde basically say, that's not science. We can't model it. Get it out of here.
Okay, so they kick out all the magic. What do they replace it with?
Computation. Pure computation. This is where the MATLAB part really comes in.
Right.
They are obsessed with the raw power of the digital computer.
Oh.
There's this one comparison in Chapter 1 that really just puts their entire worldview in perspective. They state that a modern high-performance computer working for just 1 hour can perform more calculations than the entire human population of Earth working for a full year.
That is terrifying.
It is. But to them, it's an opportunity. It means that problems that were previously way too complex for us to even comprehend, like the global economy or climate change or the history of warfare, are now solvable. We just need to build the right system kernel.
Okay, you've used that phrase a couple of times now. The system kernel. We need to unpack that because in the book, they treat this like the holy grail. What's actually happening inside the kernel?
Think of it as a black box. On the left side, you have your inputs, let's call them I of t, functions of time. On the right, you have your outputs, O of t. The system kernel is the machine, the math in the middle, that transforms the input into the output.
It's like a meat grinder. You put in beef, you get out sausage.
In a way, yeah. But mathematically, it's defined by something called a transfer function, usually written as h. And this function dictates exactly how the system reacts to the input. And this is where their engineering mindset just takes over completely. They believe everything has a transfer function.
Everything.
Everything rational. A car engine has one, right? Gas in, motion out. A lung has a transfer function. Oxygen in, CO2 out. And this is where they get really ambitious. A human brain has a transfer function.
Okay, whoa. Let's look at the normal stuff first before we get to the brain. They start with physical sciences, right?
Yes. They cover all the greatest hits of systems engineering. They model the mammalian lung, analyzing gas exchange rates. They look at predator-prey models, how the population of wolves, your input, affects the population of rabbits, your output over time.
Oh, just standard stuff. I remember doing fox and rabbit graphs in high school biology.
Right. And then they scale it all the way up to the ultimate physical system, the universe. They discuss the Big Bang and the Friedman equation, which models the expansion of space.
I noticed they spent a bit of time on dark matter here.
They do, and it's a perfect example of their logic. The standard equations for gravity and mass didn't match what we observed in galaxies. The output didn't match the input. The system had to be rational, so the math had to be right. Therefore, there must be a missing variable.
So they basically invented dark matter to balance the books.
Essentially. The model demanded it. The equations said, there is missing mass here, so scientists went looking for it. It shows the predictive power of this approach. If the math works, it can tell you things about reality that you can't even see.
Okay, so if the math works for the universe, and it works for wolves and rabbits, does it work for aliens?
The Drake equation.
I love the Drake equation. It feels like the ultimate back-of-the-napkin math problem.
It's definitely speculative, but Sandquist and Wilde treat it with the same rigorous structure as the lung. They break it down into inputs.
Yeah.
R star, the rate of star formation. FP, the fraction of those stars with planets. NE, the number of planets that could even support life.
But we don't know the answers to those variables. We're just guessing.
True. But to a system scientist, the values don't matter as much as the structure. The book uses the Drake equation to show how you handle uncertainty. You build the kernel, you define the relationship between all the variables, and then you can run scenarios. What if FP is 10%? What if it's 50? The system model lets you bracket the possibilities of the unknown.
Okay, fine. I'll give them aliens. Aliens are physical. They live on planets. They probably follow the laws of physics. But then we get to Chapter 9.
Chapter 9. Applications to social, behavioral, and other sciences.
Other sciences. That phrase is doing a lot of heavy lifting there because they try to model religion.
They do.
And I don't just mean they model how many people go to church. They try to model faith itself.
Yes. They explicitly propose variables for spiritual concepts. They actually introduce F for faith and Q for quality of life.
Wait. Stop. How do you write a transfer function for faith? How does a computer know if I'm having a spiritual crisis?
Well, let's look at their model. They define the inputs. Religious tenets, rituals, prayer, these are the signals entering the system. Then they describe a feedback loop.
A feedback loop. Like a thermostat.
Exactly like a thermostat. They argue that religious training and experience mold the mind. That molding creates a transfer function in your brain. So you pray, that's the input, and that action goes through this mental transfer function, producing an output, like a feeling of peace or a decision to be charitable. That output then feeds back into the system, reinforcing the belief.
That is so cold. It makes religion sound like a conditioning experiment.
To an engineer, it is. It's a control system. And they get incredibly specific. Did you see figure 9.27e?
The flowchart of God?
Yes. They actually diagram the Christian Godhead. You have these boxes for God the Father, the Holy Ghost, and Jesus Christ, all connected with arrows showing the flow of information and authority.
They treat the Trinity like an org chart for a corporation.
Or a circuit diagram. And they do the same for Islam. They model the 5 pillars not as spiritual duties, but as system requirements. If you want the system output salvation or community, you must provide the required inputs. Prayer, alms, fasting.
But doesn't this just miss the entire point? I mean, religion is about the ineffable. It's about mystery. If you reduce God to a variable in MATLAB, aren't you kind of killing God?
That's the philosophical critique for sure. But Sandquist and Wilde would argue, does religion affect human behavior? Yes. Does it have causes? Yes. Then it is a rational system. They aren't judging the theology, they are judging the mechanics. If it has an effect, it can be modeled.
I guess that's consistent. If you think the universe is rational, then God must be rational too.
Exactly. And if God is rational, he can be computed.
Man. Okay, let's pivot to something slightly less controversial, but just as complex.
War. War is a classic topic for system science.
But again, they don't just talk about strategy. They have equations for sinking ships.
The warfare models. Yeah, they bring up the Lanchester laws, which are these old differential equations used to predict the outcome of battles. But Sandquist and Wilde go into the granular detail. They discuss a variable called ES.
Delta ES. Change in enemy ships.
Change in enemy ships sunk. And they break down the inputs that feed into that. It's not just who has more guns. They include ship locator aerial density, basically. How hard is it to find the enemy in the ocean? They include average battle success.
It's so detached. Locator aerial density. We're talking about people dying in freezing water, and they're talking about density variables.
That is the nature of the system investigator. To solve the problem, you have to abstract the tragedy. They also mentioned combatant morale as a potential variable.
How do you even measure morale? On a scale of 1 to 10, how much do you want to run away right now?
Actually, yeah, pretty much. In historical models, they often look at the break point, the percentage of casualties a unit takes before it stops functioning as a system. It's a number. If a unit takes, say, 30% casualties, the morale variable drops below a threshold, and the system output switches from fight to flee.
So history isn't about heroes. It's just about thresholds.
In this book, yes. They even list the rise of the Beatles as a pop culture system.
That one cracked me up. The Beatles. Really?
Think about it from their perspective. Inputs. Musical talent from John, Paul, George, and Ringo. Marketing from Brian Eckstein. Timing post-war optimism. Technology like radio and TV. The output. Beatlemania.
So they think they could have predicted the Beatles.
If they had the data, yes. They would argue that the cultural vacuum of the early 60s created a system demand, and the Beatles were the input that perfectly matched the transfer function of the teenage brain at that exact moment.
That sucks all the romance right out of I Want to Hold Your Hand.
It does, but it also explains why they became a global phenomenon. It wasn't magic. It was a system reaching equilibrium.
Equilibrium. That's a word that keeps coming up. Whether it's the carbon cycle or the cultural zeitgeist, everything is just trying to balance an equation.
Correct. And that brings us back to something like the construction forecasting model they discuss. We use these models to predict how many bridges we need or how GDP will grow. Sandquist and Wilde are just asking, why stop there? Why not forecast the next religion or the next war?
So let's go back to our big question from the start. Does this book follow the philosophical path of von Bertalanffy?
I think we have our answer. They use von Bertalanffy as a credential. They like the idea of general system theory because it gives them permission to play in every sandbox, biology, theology, history, you name it.
But they don't play by his rules.
No. Von Bertalanffy was about the philosophy of the organism. Sandquist and Wilde are about the engineering of the machine. Their answer every single question isn't, let's understand the wholeness. It's, let's write a script in MATLAB.
It's not thinking about systems. It's calculating systems.
Exactly. The hero of this book isn't some philosopher. It's the system investigator, the person sitting at the console, feeding the kernel, tweaking the variables, and predicting the future.
And that leads to the part that really keeps me up at night, the determinism of it all.
Go on.
Well, if they're right, if my faith is just a feedback loop, and my taste in music is a cultural transfer function, and my career is just an economic input, then what is me?
That is the ultimate question of the computational worldview. If the human experience is a rational system, then by definition, it is determined by its inputs.
Meaning I don't have free will, I just have a very, very complex algorithm.
You might feel like you're making a choice. You might feel like you decided to eat a salad instead of a burger or decided to listen to this deep dive, but the system scientist would say no. Given your previous inputs, your health goals, your hunger level, your curiosity, the time of day, the equation in your brain had only one possible output.
So I'm not the driver. I'm just the car.
Or maybe you're just the readout on the dashboard.
That is bleak.
It is bleak. But consider the alternative. If you aren't a rational system, then you're an irrational system.
Like the tea leaves.
Like the tea leaves. If you have true free will, if you can do something that is completely uncaused by your past or your environment, then you are unpredictable. You are chaos. You are, in their view, unscientific.
So my choices are Be a math problem that a computer can solve, or be a magical glitch that doesn't make any sense.
Welcome to system science. It forces you to pick a side.
Well, I'm going to choose to believe I'm a glitch. I'd rather be irrational than just a line of code in someone's MATLAB script.
Spoken like a true anomaly in the data.
We have covered a lot of ground today.
Yeah.
From the lungs of a mammal to the delta ES of a sinking ship to a slow chart of the Holy Trinity. This book, Introduction to System Science with MATLAB, is definitely an ambitious trip, even if it does try to reduce the magic of life to a spreadsheet.
It's a powerful tool set. You just have to remember, the map is not the territory, and the model is not the reality, even if the math is perfect.
Good advice. A huge thanks to Gary, Marlin, Sandquist, Zakary, Robert, Wilde for giving us and our existential dreads so much to think about. And thank you for listening to this deep dive. Go out there and try to be a little unpredictable today. Confuse the algorithm.
Take care, everyone.
See you next time.
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.